Hello everyone, and we welcome you to today's webinar, Concepts of Advanced Surveying in GIS. First of all, Team GLOINNT would like to thank you for taking time out and being here with us today. Allow me to introduce myself to you. My name is Swati Srinivasan, and I'll be your sessions coordinator. Let me grab this opportunity to brief you about GLOINNT. GLOINNT is a global player with objective of innovating new technical ideas in the field of aerospace and other engineering sectors. GLOINNT aims to support its customer to excel beyond measurement with its innovative technical solutions. With our team's extensive experience in engineering and in-depth knowledge of advanced tools, we deliver neat and concise technical solutions in a timely and cost-efficient manner. Before entering the session, I would like to let you know that we are around 300 plus people going live from and across India. We would appreciate you to type your doubts or questions in the comment section with your name below. And at the end of the session, some of your questions will be clarified by the trainer. Without much delay, let me commence the webinar. I hand over the session to the host of the webinar, Mr. Mohammed Sheikh Ismail, GIS engineer and technical trainer of GLOINNT. Over to you, Mr. Ismail.
Good morning, Swati. Thanks for the lead, Mr. Swati Srinivasan. Greetings, everyone. My pleasure to introduce myself to you. I am Muhammad Sheikh Ismail. I'm working as a GIS trainer with GLOINNT Solution. It's cheerful to see you, all participants here, and I am so thrilled to acknowledge the dedicated response from GIS across the India and abroad. So here, I had a great time hosting this webinar with all of you. I hope you learned, and I hope you people will learn a lot actually. So like this webinar is exclusively scheduled for the academic students. I hope students will learn a lot and especially will move forward. Yes. So introduction to geographic information system. So what is meant by geographical information system? I hope all the students and all the participants are coming from civil engineering, geology, geography, and geographic, and all the related departments to geographic information system. I hope you all know about the geographic information system. It's nothing but we'll go to that. GIS is an emerging technology itself. The field of geographical information system is constantly evolving in each and every sector, especially in civil engineering domain. Over a span of 20 years, GIS technology is a crucial part of spatial data infrastructure, and it can use any information that includes a location. For example, so as I told, the basic things. What is GIS? No, the getting the information about the geographical earth features in a systematic manner. That's how the GIS expands a lot actually. So as I told, this span of 20 years, it's evolving everywhere. So like this location can be expressed in many different ways, such as latitude and longitude, address, or zip code. However, so end of the day, everywhere we all work together in order to get some location-based information. So like, and what is GIS? This is probably the most asked question posed to those in the geographical and system field, and is probably the hardest to answer in succinct and a clear manner. So GIS is a technological field that incorporates with tabular data in order to map, analyze, and assess real-world problems. Yeah, of course. Finally, we are using GIS for straightforward map making. Okay. So I told already the GIS also in terms of generally academics and all the books. So it's like designed is exclusively designed to capture, store, manipulate, analyze, and manage, and then exactly present all type of geographical data as a map. So how you can capture something? So like as I told, this is nothing but geographical system is exclusively getting the information about our geographical futures. That is nothing but a geographic feature. Roads, buildings, trees, rivers, whatever it may be, cars and whatever, bridges, anything. So it's all about collecting the information about our geographical earth features and how you can collect the features. What is that? By using, so earlier you all know about collecting data. Okay, what is the name of the building? Like through mouth itself, what is the name of the building? What's the name of the that road? What is the name of the pond? The name of the pond, something that is also comes under the data collecting. And next to that, people are started using surveying technologies like chaining, ropes, tapes, theodolite, total station, eye level, dumpy level, all the surveying technologies. That is nothing but capturing. Capturing is nothing but collecting the information about the geographical system, geographical futures, the earth objects. So, like in the modern era, people are started using drones. Hope you all know about the drones, right? So, like in the videos, wedding events. So everybody started capturing the images for videography using drones. Of course, we are using drones, particularly nowadays in every field, to capture the geographical features from the top. That is nothing but aerial view. So like, and next to that, store. What is that? Storing means what exactly? Storing something on some location. So how? What is that exactly related to GIS? You will be storing your captured data with the help of any GIS technology in some storage device. So in the early day, people started doing the surveying process with the help of chains, total session theodolite, and how they can store in some storage devices. Did they have any guess? No, absolutely. They are storing all the data into paper format, hot copies. They are short mentioning, keep recording all the values in a book set. So now it's a modern era, so everybody started using gadgets, right? So we are storing our captured data, whatever it may be, points, single points, Excel sheet, like images, anything. So we are storing that in a storage device. For example, SD card. Okay, and the manipulation process. So the captured data about the earth surface will be storing into the device, and you have to manipulate to process the stored data. Why it's necessary to process the stored data? Of course, yes, because whatever the input coming in the GIS domain, the most output coming from the GIS is nothing but a map. But creating a map is not an easy task, that's really tough. But of course, everybody can do that. Everyone can code, no? Everybody can map. We have to process the stored data by using what exactly? Softwares. Like that is a soft because you capture data from hardware and you have to store somewhere in the chip or any storage device. And next to that, you have to process your stored data to get some quality output as a map. And fourth one, analyzing. What is meant by analyzing? You all know the not a basic analysis, no? To prepare a nice map based on the client's requirement, based on the client's end user expectation, you should analyze what you have to expose in your map and what you have to, I mean, but you have to process what is the methods, what are the methodologies are there to analyze your data to get a quality output. So analyzing is not an easy task with the help of software. So captured data will be stored in a cheap storage device and the processing will be happening in the software. There are open source softwares are there, proprietary softwares are there. So depends on the client's requirement, the budgeting activities, you will be moving forward with the analysis thing. So after the analysis, so what you can do exactly? Present all type of geographical data into map. See the right hand side. So the bottom layer will be real world. So like I captured, I mean the surveyors or the data collecting, I mean data capturing engineers, executives, they capture data with the help of surveying instrument, for example drone. I capture images from the top view and then start processing the data in order to prepare. See the outputs are the land usage. There is nothing but land use, land cover maps, something, for example I'm saying. So I can segregate what is vegetation area separately, build-up areas, water bodies, wasteland, everything. I have to separate, I have to segregate, I have to classify all the data based on my expectation or client's expectation or end user expectation. And also I can get the elevation data with the help of GPS and parcel mapping. I need to convert all the map into multiple parcels, depends on the land boundaries or the building boundaries, whatever it may be, and street maps, and then customers are there. So we have a lot of things to do based on our need, based on the client's expectation. We have to move forward with that. Okay. I hope you can understand what is GIS. Capturing the data by using surveying equipments and storing into the any storage devices and processing with the help of software, analyzing and managing, and then finally presenting all the geographical data as a map. You go to the next slide. Okay, cartography. What is in the cartography? We all know that photography, biography, geography. What is my cartography? Yeah, let's have a look onto that. Cartography is the arts and science of expressing the known physical futures of the earth graphically by maps and charts. Yeah, that's of course arts and science of making maps. So what is that? What is the in the cartography? The study of making maps, because anybody, not anybody can prepare map, but everybody can make maps. Who can prepare a map? Only who knows the procedure, the methodologies in a perfect way, right? So like that cartography, I mean the study of making maps includes geographical data, geodetic data, political and cultural information is completely fed into computer, I mean the processing environment, and stored until a particular map is needed. So like who prepare a map exactly? So some person is drawing a map there, right? And who can prepare a map exactly? Only the cartographer can prepare a map. Who is the cartographer? The person who prepares a map. Photography, no? Who's the photographer? The person who's doing the photography. The same thing. The cartographer is the person who's preparing a map. Okay? Yeah. We'll go to the next slide. Okay. Let us discuss about the data capturing process in civil engineering domain. And I request everybody to have a look onto this data. Okay, so I request everybody to have a look onto this data. So I'm giving you some data visualization. Just have a look. What kind of data is that? You can guess yourself. So like it is a kind of data captured from some aerial platform. So it captures trees, roads, buildings, cars, and sheds, bushes. I mean, in the roads also, the circle in the road. I mean, and the roads also, that system is capturing the median of the road, right side end and left side end, the embankments of the road, everything. Perfectly, they started capturing data. This is kind of data visualization. You just think about that. So how many earth features are there? One, two, three, four, five. Main, actually here we have five major roads and one, two, three, okay, approximately 20 plus trees, and the area will be covering nearby 50 plus acre. Okay, and you have 10 plus buildings. A lot of geographical earth features are there. So now my question is, let us discuss about the data capturing in civil engineering. Okay, so my question is, if you use some instruments like total station or theodolite or any kind of civil engineering core instruments, yeah, of course GIS is a part of civil engineering like environment, agriculture. We have lots of domain, structural transportation. So including that, GIS is a part of civil engineering. Okay. So now, if you start using that, if you start using that total station some civil engineering instrument, how long it will take to cover and do surveying all the process? At least it will take 3 to 4 days, right? So you have to find some good elevational points with the help of the GPS system, and after that you need to set basic instrumentation, and you need to establish your instrumentation depends on the area coverage. You should take some time, at least you should need to help us to complete the whole survey project. So what I'm trying to say, we'll have a look into the advanced surveying concept. These data is captured by drones from the top at least 50 meters height. So what I'm trying to say, I can capture the whole area within 1 day. I mean, I can able to deliver. I mean, so I'm representing the GIS community exactly. The GIS community, whomever is working on GIS, they can produce the whole area maps. They can within a single day with a greater accuracy when compared to the basic instrumental surveying like fluorescent light. If you want to measure any vertical distance or horizontal distance, any bearings, at least you should need 2 or 3 instruments moving forward. Only one instrument is enough to capture all the area within a half day. And the next off, you can produce a quality map. So like how can you produce that? Capturing the data from here, it start converting all the data into precise GPS values in the software, some appropriate software. This is how moving on. So you can think about that, how the GIS concepts are evolving every day. It is there since 20 plus years, but we're all using that. Only few colleges are having that academic program, and others they are trying to learn from outside any organization, any kind of instruments. So like everybody should think about that one surveying using drones or anything whatever it may be. We'll see that in the next slides, upcoming slides. See in the right side, two images. One who is handling some totalization or some kind of instrument with the help of which is mounted on the tripod, and the second one image they started measuring using plumb bob, something to in order to measure the elevation. I mean the rugged terrain, vertical elevation distance. Okay, so see how you should keep these two images in your mind. Moving forward, let's discuss about the data capturing, how it will be done. So like, I would like to say something about civil engineering to civil engineers and all the people, with all the participants who is coming from the background, any background, geology, geography, something. Okay. So civil engineering is a profession, every professional engineering domain and discipline that deals with the designing, estimation, construction, maintenance of the physical and natural built environment. So how can I say that? Everybody, yeah, civil engineering is having multiple departments, structural department, transportation department, designing, estimation, construction, maintenance, etc. It is a big domain actually. So it's all about developing and sustaining infrastructures in the world, especially. So this profession covers many area of interest and a broad range of expertise. As a result, exactly, civil engineers works with a voluminous amount of data from variety of resources. Of course, we all know that. Okay. Next to that, I will I would like to give some introduction about surveying. Surveying is a art. It's an art of making suitable measurements in horizontal and vertical plans. Surveying equipment such as levelings and theodolites are used to measure something on the earth feature. Exactly used to for accurate measurement of angular deviation, it is horizontal, vertical, and slope distance. Although Surveying is a distinct professional with a separate qualification and licensing arrangements, and engineers are trained in the basics of surveying and mapping especially, as well as geographic information system. So surveying, basically we are used to measure the land, measure the land features, that is earth feature. What are all the earth features? The mining, agriculture, construction means what? Not only the building construction, road construction, bridge construction, railway construction, etc, etc, etc. So whatever the construction process, surveying is the particular one should be needed to construct all the features perfectly. How you can move forward? Your measurement should be precise, so then only you can construct perfectly, right? So how you can measure usually in the surveying? How the surveying are classified? Let's see in the next slide. So types of surveying. Types of surveying is absolutely classified based on the nature of field. There are three types of surveying classified based on the nature of field. The first one is land surveying. Of course, you all know that it deals with, general deals with natural or artificial features on the land, such as rivers, buildings, roads, streams, lake, forest, hill areas, whatever, etc., etc., etc. Canals, towns, building, and all the geographical properties. And the next one, the mine surveying, it deals with the water bodies, not exactly mine, sorry, marine survey. It deals with the water bodies. It deals with the bodies of water for the purpose of navigation. For the marine navigation, you should need some your positioning system in order to navigate from one place to another. It's not only in marine, in everywhere, anywhere in the earth feature, you should need some positioning system to navigate from one place to another place. So, like not only for the navigation, some harbor works in order to construct the harbor, renovation of the harboring or modification of the ports, anything, etc., etc., etc. Okay, sometimes the marine surveying will take a part in the bathymetric survey also. The bathymetric survey in order to understand the depth of the water and the any features available on the water, but like glaciers or something, etc., etc. So the land surveying is completely different from marine, and marine is different from land surveying. And astronomical surveying. The astronomical surveying, it offers the surveyor means of determining the absolute location of any point or any of the absolute location of and direction of any line of the surface of the earth. This consists in observation to heavy bodies, heavenly bodies such as the sun or any fixed star. So when you compare all the three types of surveying, a land survey, it deals with the land bodies. The marine survey deals with the water bodies. The astronomical survey deals with heavenly bodies. So these three surveys are based on the nature. Next to that, okay. So types of survey based on the object. So first one, geological survey. A geological survey is the systematic investigation of geology. You all know, if it is comes under the geological term, it always deals with the geological features. A given a piece of ground for the purpose of creating geological map or any model, that may be 2D model, 2D maps or 3D maps, 2D model or 3D model, to understand the deeper analysis and the deeper concepts of the geological features, whatever it may be. Again, when it's come to mine surveying, mining is a great domain actually, quarry or anything, whatever it may be. It includes all measurements, calculations, and the mapping at all the stage from prospective to exploitation and utilizing mineral deposits both by surface and underground works. It deals with exactly measuring the cuttable area, that filled area, cut area. So like you can understand the volume of the mining, what is happening there exactly by surveying process. It gives you the exact measurements and the perfect calculation and all the mapping process. When it's come to the archaeological surveying, it's a types of survey. It's a type of survey. It deals with the archaeological research field, distribution of the human cultures and the organization and the beginning of the human culture all over the world, organization of past human cultures across a large area, the migration of people from one place to another so over decades. Archaeologically, it helps you to understand the archaeological terms exactly. So how long that futures are older than nowadays. You can understand the age of some archaeological buildings or any objects, something like that. That surveying is comes under archaeological term. Next to that, military surveying. Military surveying raised under military intelligence. So like identifying the border changes, detection of changing borders, identification of intrusion of some illegal movements, and a lot of things are there to provide the maps to army, navy, or air force. What kind of maps? For example, I'm giving you a war country war timing. So like you can able to identify to you can able to spot a particular location of terrorist or their enemies camp, something like that. By capturing images using drones or helicopter, aeroplanes, whatever it may be. So with the help of the map, the army people or navy air force people, they can move there and attack them with the right time or the right effort. So these military survey will be useful for that kind of things. And next to that, types of surveying is based on the instruments. As I told already, chain surveying, compass surveying, plane table surveying, theodolite surveying, tachymetry surveying, and photographic surveying. So what is meant by chain surveying? See the first image. You are the surveyors are handling the change to measure the distance from one place to another place. The compass surveying, next to that, it helps you to understand the bearings, and with the help of bearings, you can calculate the distance between two objects, and it will help you to navigate from one place to another place also. It gives you the perfect direction. When it's come to the plane turning, it will be mounted on a tripod and placing a paper over there with the help of validate and some other instrument. We started marking all the geographical features, whatever the available on the opposite side in the surveying area, and you start doing surveying process in your plantable system. And theodolite, it is the second decade after the chain, compass, and the plane table. It gives you, it is inbuilt with the telescope, which gives you the vertical and the horizontal distance. The horizontal distance will help you to understand the distance with the help of the angle between 2 points. The vertical distance, again, it will help you to find out the heights of any building or any future on the earth surface. The same like tachymetric survey and the photographic survey will be done. Okay. Okay. Next to that, types of surveying based, it is classified based on the method. There are two types, especially triangulation surveying and traverse surveying. In the triangulation surveying, the process of determining the location of a point by measuring only angles knows from one end to another end, it is having a baseline. For example, the triangle surveying, the simple concept is you start dividing the area, the given area, into multiple triangle. So by using the Pythagoras theorem, if you have a two angles or one side or two sides of one angle, you can able to find out the distance between one place to another place, right? With the help of that, you start dividing the area into multiple triangles. Okay, so with the help of that, you will be getting area of a single triangle. While combining all the data, while joining all the area of the triangle, you will get easily a total number of area. When it's come to the traverse surveying, it's a method in the field of surveying to establish a control points. It is a linear and the long survey. Okay, a networking involves placing survey station along a line or path of a travel, and then using the previously surveyed points as a base observation for the next point. So I start continuing the work along along a line or a path of a travel. Okay, in that thing concept, the second part, next part of the travel surveying will be considering the previous point as a base point, then start measuring that. This is how the types of surveying are done. When we talk about the concept of advanced surveying, nothing but the study of advanced surveying concept helps us to understand how conventional system of land surveying have been replaced with advanced systems such as total station, GPS, remote sensing, and GIS. GPS is nothing but global positioning system. It is giving you the positional value of yourself with a greater accuracy. Exactly. Okay. For example, I'm giving one great domain. Lidar. You consider a Lidar. Lidar is considering as one of the advanced surveying method. We have lots of surveying method. I am considering and I am keeping Lidar as a one of the advanced surveying method. When we talk about a Lidar, it is one of the concepts of advanced surveying. So LiDAR, it stands for light detecting and ranging. Of course, hope you all know about the remote sensing technology. The remote sensing, what is meant by remote sensing? What is meant remote exactly? Remote, without making any physical contact. That is what remote, right? Sensing, what exactly means sensing? Sensing some air features without making any physical contact. That is what exactly remote sensing. Why these LiDAR comes under the remote sensing concept? What is this exactly? Of course, LiDAR is absolutely, and of course, it comes under remote sensing technology that uses light in the form of pulsed laser to measure or ranges distance between two objects or any target from the instrument. And it is emitting a beam of laser light and then measures the distance, depends on the speed of light and how long it takes for the light to return to the sensor. See the diagrams. The lidar sensor, it will be emitting a laser. It will be emitting a laser. By emitting the laser, when it is hitting the target, it will be getting back to the system. Based on the time traveled by the laser beam, we can able to calculate the distance between the target and the system. If you start if you start emitting your laser pulse towards a two different objects, with reference to your system, you can measure the distance between two objects and the angle between two objects with the instrument station. This is how the things are happening. See the right side, LiDAR unit will be mounted on the aircraft. Okay, and a laser pulse will be start emitting when it reaches the surface and it is getting back to the system. Depends on the time traveled by the laser beam, we can measure. Someone can ask a question like how you can measure the distance by the light, the traveling of the light. Okay, okay. Thing is that OPL knows about the speed of light, 3 into 10 power meter per second. The same thing is here. The laser is comes under the light category. There is some components will be built in the LiDAR system. Let me go to the next slide. Based on that, we can easily calculate the distance. We'll see that. What are the components will be helping to understand that. See the components of LiDAR. A complete LiDAR system is made up of several components. All of the components work together to generate, record, and georeference the data. The main components are LiDAR source, detector, LiDAR detector, and scanning mechanism. The LiDAR source is emitting the laser pulse from the instrument, from the device. And the detector, it is detecting the targets, whether the laser it is reaching the system or not. Okay. And the scanning mechanism, which is emitting laser pulse from the system. The source, LiDAR source, it is generating the laser pulse. The scanning mechanism is emitting the laser in order to reach the surface and getting back to the system. And the timing electronics. What is meant by the timing electronics? What, sorry. Okay. What is meant by timing electronics? Here, I told already. The laser pulse, it holds the characters of lidar. I mean light. When the laser pulse started emitting from the field, I mean from the instrument to the object, it is holding the characters of lights itself. The timing electronics will keeps recording the time traveled by the laser from the emitting to after reflecting back to system. Okay, the time alarm it keeps recording the time traveled by the laser. And then global positioning system, each and every point what you are capturing there with the help of lidar sources, it is giving you the latitude longitude values, it is the coordinate values, not only lat long values. If you have a high accurate lidar components, that will gives you the z axis also, x y z, latitude longitude and altitude. Okay, length breadth and height, I mean x y z axis, height also will be given that. So the inertial measurement unit, what is that? IMO. IMO is nothing but it starts maintaining, it starts balancing the position of the scanner. For example, hope somebody knows about the gimbal technology in the camera. Like no, if you start moving when holding a camera, still the focus will remain same on a particular object. How is it possible? You started moving here and there. How is it possible? With the help of gimbal technology. The inertial measurement unit IMU will be installed in between inside that. What is the purpose of the IMU? It is helping you to keep balancing your XYZ axis. Sometimes your focus will not change the particular object perfectly. Row, roll, yeah, pitch. These inertial measurement unit will help you to maintain XYZ, roll, pitch, yeah. Okay, and the computer. These are all the main components. This computer is a hardware where you can monitor, where you can process your data while surveying process, while doing the surveying process, while processing the data itself. Okay, this is how the components of lidar are happening. Okay, when we go to the, yeah, in the GPS itself, your system should be connected to at least 3 satellites in order to get precise latitude longitude values. Okay, next to that, the concept of lidar, as I told already, is a remote sensing method used to examine the surface of the earth. These light pulse combined with other data recorded by the system, generating precise or three-dimensional information about the earth surface. It is giving the exact shape of the earth. It's all about surface characteristics. What is my surface characteristics? Giving you the each and every details about the earth surface in an accurate data. Got it? Okay. Next slide. What are the advantages and disadvantages of LiDAR? So here I'm giving you few advantages and disadvantages. LiDAR, it is high accuracy, perfect, high accuracy when compared to all the technologies in surveying. And it is high data density. While capturing the data, it will takes place a lot of storage to store, because it is high voluminous amount of data, high volume amount of data. It is higher density of data. The acquisition of data and the processing is very, very fast. If you can capture some area, for example, 5 months, I can capture the whole year. If you civil engineering domain, in civil engineering domain, if people are started capturing with the help of total station, the area for 5 months, GIS people with the help of Lidar can capture that in only 1 week. Whatever. We have a different types of Lidar method, different types of Lidar. The help of Lidar, with the help of different types of Lidar, we can able to do the fastest acquisition, and processing also will be very fast. And it is of course minimum human dependency. Two people is enough actually for data collection. I'm telling about that. 100% reliable. You can start processing your data with greater accuracy because it's 100% reliable. And the disadvantages are high operating cost. Precise alignment must be maintained effectively. Ineffective during heavy rain or low cloud or mist. Lidar is highly degraded at very high sun angles and reflections. That is also light. This is also light. Obviously, it will be degrading light. Lack of vegetation penetration. Got it? Yeah. You go to the next slide. I told about the types of LiDAR. What are the types of LiDAR are there? Aerial LiDAR, mobile LiDAR, terrestrial LiDAR. Hope you all guessing the point. Aerial LiDAR. What is it? My aerial? Aerial. Okay. Aerial LiDAR. Let's see something about that. Airborne LiDAR is nothing but aerial LiDAR. Is when while attached to the aircraft during flight. If the lidar started capturing the futures, the earth futures from the top, that is from the above the ground surface, that is aerial platform, that is aerial lidar. Okay, well attached to the aircraft during the flight, and it creates 3D point cloud model. The output from the raw data, the raw output from the lidar is point cloud. Okay, this is accurately and currently most detailed accurate method of creating digital elevation models. Of course, it's replacing photogrammetry, giving like greater accuracy actually. And what is meant by mobile lidar? Hope you all can able to see the images in the right side. The first one is a data collection, data capturing process. Second one is output. I think you can guess that mobile lidar, also mobile laser scanning, is when two or more scanner are attached to a moving vehicle to collect data along the path. Mostly these mobile lidar will be used for corridor mapping, extending the roads, 2 lane to 4 lane, 6 lane, something like that. It is we are using mobile lidar mostly in the existing future like roads, um, rail roads, airport. I mean the roads and rail roads. Okay, these mobile lidar will be especially used to capture the future which is nearby, which is side of the system. Mostly we use for corridor mapping and roads. I mean existing future, some kind of things, detailed information in the earth surface. These scanners are almost always paired with other kinds of equipments, including the GNSS receiver and IMUs. One example application is surveying streets where power lines and EV poles, bridges, trees, medians of the roads, embankments of the roads, building heights and elevation of the buildings and everything, whatever it may be, street lights, and any cars we have in the thing, and post box, anything, all those things. If you start capturing your street with the help of mobile lidar, it will capture power lines, bridges, anything, etc. So like mobile lidar will be attached to moving object, moving vehicle, on the top of the vehicle. Okay, hope you can see that in the first image. It started capturing the surrounding features, and the output will be like that: bus stops, everything, anything, etc., etc. Signboards and culverts, everything perfect. Okay, and when you talk about terrestrial lidar, it is a terrestrial laser scanning that happened on the Earth's surface. It can be mounted on the tripod and used for a mostly conventional topography. With the help of a terrestrial lidar, we can measure X, Y, Z axis for indoor surveying or outdoor surveying. It is mounted on the only tripod. It will not move balloon. Same thing. It start capturing the futures 360. Okay. When you compare all the three lidar system in a single platform, aerial lidar is what exactly? You start capturing futures from the top. Not only the aeroplanes, drones, helicopters, you start mounting your lidar system, lidar sensors on the bottom of the flying object that starts capturing about all the earth surface with a minimum height or a maximum height, depends on the vehicle. And mobile lidar mounted on the top of the car, it start surveying the futures nearby Earth surface, meaning nearby the layer system. There's lidar mounted on the tripod, and it start capturing the futures, measuring the futures, calculating and surveying the futures. Okay, hope you all got the idea about all the three lidars. We move to the next slide. And role of GIS in civil engineering. GIS is interoperable and it's transforming, disrupting, and expanding ways to engineers to serve our society. It provides layers of data on top of geographical maps that can help engineers to make better informed decisions. They can take a calculated risk, better decision making, troubleshooting the problems. It is very really useful. Whenever you have a location based problems in our domain, GIS will help you nicely to solve, to troubleshoot the issues. It is supporting many data formats used in all the domains mostly. Again, it's allowing civil engineers to provide to various agencies in the required format while maintaining the data core integrity, which means civil engineer may have a lot of clients in over all the domains: oil and gas, agriculture, mining, accounting, financing, aerospace, IT sector, banking sector, everywhere. It is it will give you the data in the required format. Okay. And next to that, GIS solutions for civil. The first thing is CAD integration. Okay, so integrating your CAD, your data in GIS format. The first one is the first one is civil engineers always using the CAD format. CAD is nothing but computer aided document. You started you started designing all the surveyed futures on a particular software. And that software is not exactly your referent one. I will tell you a difference between civil CAD and this CAD. Only it is both things are perfectly what no computer aided documents. Okay, if people are started started designing, I mean, new proposal. I mean, if there is no reference, like no proposal, like if you are proposing a plan for any buildings, that is civil CAD. If you are designing existing future on the earth surface, that is GIS CAD. And then site analysis, infrastructure management. Okay, infrastructure management, 3D modeling, advanced surveying, urban development, town planning, land asset management, transportation planning, building information modeling, site inspection. These things will be really helpful. It gives a perfect solution for civil engineers. Okay. Okay. And I would like to give a detailed information about the support from Team GLOINNT for academic projects. What we do, what are the features of that? More options. We give academic support to all the academicians, the project support, more options to choose the subject, 100% involvement of the students with the industrial expert in order to improvise and improvise their skills and enhance their knowledge. Absolutely, it is one-to-one discussion according to their project. We have a 20 plus years of experience to guides in our company. Will guide them to understand the deeper concept according to their academics. Completely professional approach. Our area of specialization is aerospace technical publication, geographical information system, and design engineering. Okay. Okay. So in aerospace technical publication, it is the core of the company, and we give support in geographical information system also, and a designing engineering is also there. Okay. Okay. Next to that, geographical information system. We are expertise in these major domain. What are the services will be providing from our company in the domains of agriculture, mining, infrastructure, energy, then roads and highways. Okay. Next to that, list of instruments and services we are handling. CAD works, quarry surveying, monitoring and quarry monitoring and mapping, topographical mapping, contour mapping, generation of DEM, DSM, DTM, that is digital elevation model, digital surface model, and digital terrain model. And then Lidar data processing services, and then corridor mapping. Okay, and instruments are UAV, unmanned aerial vehicle, Lidar system, that is aerial Lidar, mobile Lidar, test Lidar, DGPS system, differential global position system. We do services on these categories, and we can handle these kind of instruments. Next to that, I would like to introduce you about our skill development program. Okay, I would like to skill development program. The eligibility for the skill development program is people who can join from geology, geography, geoinformatics, civil engineering, and all the related departments. It's absolutely 2 months program, and the highlights of the program are you will be giving introduction to and fundamentals of GIS, surveying and map making, building GIS layers, and exploring GIS data formats. Geospatial data services with location intelligence. You will be learning all those things. Then data visualization and WebGIS concept. For absolutely the placement assistance, students or candidates have to complete the practical mode of training, including software at GLOINNT office in Bangalore, besides the online training. Okay. Yeah, and I'd like to say one thing. We give 100% placement assistance to all the students till now. Okay. So like this will be a question and answer session. I had a great time hosting this webinar. I hope everybody learned and enjoyed my presentation. And I would like to hand over the session to Ms. Swati Free. to continue with the question and answer session. Swati?
Hello once again. I hope you had a solid session with Mr. Ismail. I would like to make a small announcement here. Since it's a free webinar and hence certificates will not be provided to all the participants. Participants who would like to avail certification has to contact us in person. You can mail us or call us for further information. Moving on to the question and answer session of the webinar, our team has shortlisted some of the applicable questions from the comment sections. I'll read it out to assist Mr. Ismail. So some of you has asked that whether we will be uploading this video for further reference. Yes, of course, we'll be uploading this video. And I have one more person asking for software training. You can contact us and we will give you the further information. And regarding the Marine GIS training, so I would like Mr. Ismail to pitch in and say what actually is marine engineering.
So marine engineering, as I told, it deals with the water bodies, exactly. And in marine engineering, GIS plays a great and important role of understanding the marine environment. In particularly the marine environment, it can be adopted and utilized to assess managing the spatial features and the water bodies, and to study that, to go into the deeper understandings of marine features like oceanographics and coastal and studies and coral reef studies and all those things. So like many companies are doing that, even the government organizations are helping us to understand sometimes for example oil spills and plastic, I mean non-degradable wastes and the water bodies, especially in the ocean and the sea areas. So we started doing the marine survey in order to neglect those future for perfect and good going environment. Of course, as I told, marine, it deals with water bodies, getting a detailed survey in depth with the oceanography and all those things. Okay, hope you can understand that, like coastal and the shoreline studies and etc. 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 Okay. Okay. So I hope you got a clear idea about the marine surveying. Okay, guys. Yes, what? Any other questions from participants? What? Okay. So role of drones in surveying, especially. Okay. Yes, what? Yes.
Sorry for the interruption, actually. So first of all, I would like to apologize as due to the pandemic, we are all working from home and there is, of course, technical issues here and there. So I think we have answered to most of your questions and we'll be posting this video online. So I would like to give a thank you note now. I, on behalf of Team GLOINNT, would like to extend my hearty vote of thanks to all the participants for the consistency and involvement throughout the session. Stay safe and do let us know the feedback of the session. We have posted the link for the feedback form in the comment section itself. Please do take your time, go and fill our feedback forms. Thanks a lot.
And again, from my side, and behalf of GLOINNT, I would like to thank all the participants for your patience. And I hope everybody learned a lot. And we would like to extend and keep in touch with us for any queries. You can contact us back. Okay. Thank you all. Thank you so much. Thanks for the nice webinar.